I'm going to walk you through our stepper motor example. First thing you want to do is set up your hardware, and in this case I've already got it set up for an ACE 11, but right in this section here you tell it how many stepper motors you're going to use by just selecting the pins that are used. You can do this for up to 3 motors, and you just give it assign it which digital output pin you want for the step and which one you want for the direction. In this example, we're just going to use 1 stepper motor. Okay, and once you've done that, then you write your logic. And this particular example it's a very simple one. We set it up as a state machine. If you're not familiar with that, check out our tutorials page. You can see some other examples of state machines. But what a state machine does for you is it lets you go. You start out in one state, and in this program, I'm telling it its state equals 0, and state's nothing magical. It's just a tag we created, and we're giving it value 0, and then we go ahead and we start our logic, and we go one state at a time. So state is equal to 0, and if it is, then we're checking an input bit. This is a digital input in this case, and if it is on, then we're going to start our motion sequence. If it's off, then you see we take the no path and we loop back around. And this whole set of logic, it's all one big loop constantly trying to execute. That's how all state machines are. Anyways, if the state equals 0 and the bit it happens to be on, then we're going to do a move to a motion out statement. You can see in our toolbar here, motion out. That is what gets us there. And I'll actually double click on this and show you how we have it filled out. You can, in this tool, you select which motor to use. In this case, we only have 1 motor set up, so you can't click on the other ones. But if you had other ones set up, you'd be able to select which one you were talking about. And this tool allows you to do one of 2 things. You can either move to a location, or you can just tell the motor to stop, and it'll just stop where it is. So the first motion, we're telling it to move to location 200, and we're telling it how fast to move at a pace, in this case, of 500 pulses per second. And we've got a soft start length. It says take 500 milliseconds to get up to this speed, or if you're at speed, take that long to get back down to 0. Don't do it immediately at that speed. Ramp up and ramp down. And then we're storing the current location of the stepper. So as it's doing its motion, as it's reached its 130th step, that's going to be you'll know that based on you can query the value of location, and you can know exactly where you are. And you'll see we're just about to use that information. Okay, so we tell it to go to location 200 here, and then we move the state. We tell it place the value of 1 into state, and then we wrap around, and you see the next thing we do is we state will be equal to 1, and then we ask the question, is location equal to 200? Have we reached that destination we were trying for yet? If not, which it won't be at first, it'll loop back around, and it'll just keep asking the question. Eventually, the motor will get to that location, and it'll move to its next thing where we're saying move to location 0. That's the only thing that's changed in this block is go. You're going to go back from location 200 to location 0. What that'll cause, it'll cause the direction the direction output to reverse. It'll be going the other direction this time, going back to 0, and then it'll send out all of its pulses. And okay, we're going to tell it to state should be value 2 now. We loop around, and you see at this point we're going to go to location 400, and then the next time we'll go back to 0, and then to location 600, and then back to 0. And when we finally have determined that it's made its final movement, location is back at 0 again, we bring it back to state equals 0. And again, this one, it will cause the motion to repeat itself if the input is on. If not, it'll just cease there until the input is on again. So we can go ahead, and I have this plugged into PLC with a simulator stick. So we can actually debug this. You can see a little bit how it looks. So I'll program it. We'll tell it to run, put it into debug mode, and we can look at we can actually look at the locations where they currently are. That'll be on the left side of all these comparisons where I put the location value, and you can see based on the color here which state it's currently in. So it's hanging out here. If I were to put a breakpoint here, we could step through, and you'd see, okay, so it's following the no path. It's just looping around here. It's just going through that forever. Okay, now if I were to flip the switch, okay, you see this green now. It's going to now start going to the actual motion steps. So I'm going to let this run, and we can just keep an eye on the left side of this number, and you'll see it increment and decrement. So you see it going up. It actually happens quite fast. So it's going down and up. I still have the switch on in the on position, so you can see it. It keeps going through its sequence. And I'm going to go ahead and I'm going to flip the switch off. So once it's done with this whole pass, it'll hang out there at step equals 0 until we tell it to go again. Okay, so it finishes path. Now it just hangs out there. So we'll go ahead and provide the software for this example on the tutorial, on this tutorial page, and this one happens to be for an ACE 11, but you should be able to easily convert it to work on whatever PLC you've got.